We're at Garland Solar facility today near Bakersfield, California. My name is Jeff Burleson. I'm Senior Vice President of Environmental and System Planning at Southern Company. In my role with the company, I actually have the opportunity to sort of oversee and lead our net zero strategy, as well as our long-term generation planning and generation development. In May of 2020, Southern Company set an ambitious goal to achieve net zero greenhouse gas emissions by the year 2050. What that means is the company's going to do all we can to reduce our direct emissions of greenhouse gas. Net zero in terms of greenhouse gas emissions is really important for not just our company, but for the overall U.S. and the world in and of itself. Ultimately, the intent here is to try to limit global temperature rise. The objective is to try to keep it from a net zero standpoint to 1.5 degrees C or less. We've already made a lot of progress towards our greenhouse gas reduction efforts. In fact, through 2019, we had reduced greenhouse gas emissions by 44%. And through the end of the year 2020, we've reduced greenhouse gas emissions by more than 50%. And that's compared to our baseline year for greenhouse gas emissions, which is 2007. Our 2050 goal is a very ambitious goal, and it's going to take a concerted effort. For us to be able to achieve net zero emissions, what we're going to have to do, obviously, is to continue to transition our generation fleet towards low and no emitting generation resources. We're also going to have to continue to reduce the carbon impact of our natural gas business. Solar is going to play a big role for us in achieving our net zero goal. Particularly in the Southeast, where our regulated utilities are, solar is our best resource. But of course, in other parts of the country, wind plays a big part as well. So we're not only trying to drive improvements and lower greenhouse gas emissions in our southeastern states, we're trying to help the entire economy and the rest of the United States do that. And we're going to have a focused effort on technologies that really will sustain and enable us to achieve net zero. Those technologies would include things like long duration energy storage. They would include energy efficiency technologies, carbon capture and sequestration, advanced nuclear, electric vehicles. We've got to ensure that we get strong proliferation of electric vehicles. It's going to take all of those things working together in order for us to be able to achieve net zero overall. Once you get to high penetrations of either solar or wind generation, you need some energy storage to really back that up. And battery storage is a good short and intermediate duration storage technology to be able to do that. Energy storage is going to be an enabler to allow us to integrate in large amounts of solar and wind into the overall generation mix. And in addition to that, negative carbon solutions, planting trees or other things like that, biomass generation with carbon capture and sequestration, or direct air capture, some technologies like that. So this is an ambitious goal to get to net zero by 2050, but we've already got a great start. One of the nice things is that Southern Company has been able to reduce greenhouse gas emissions thus far without any mandates. We've been able to do it because of the economics of retiring some of our coal plants, implementing solar, implementing energy storage, implementing wind. Those things are cost effective for our customers, and with the right research and development focus, we'll be able to drive down the cost of those other low and no carbon resources to the point where we'll be able to achieve net zero in an affordable and reliable way for our customers.
In 2020, Alliant Energy set an aspirational goal to achieve net zero carbon dioxide emissions by 2050 from the energy we generate.
In January of 2020, APS set a bold goal to provide 100% clean, carbon-free electricity to our customers by the year 2050. This goal includes an interim target to achieve a resource mix that's 65% clean, with 45% of our portfolio coming from renewable energy by the year 2030.
Consumers Energy is committed to achieving net zero methane emissions by 2030 and net zero carbon emissions by 2040.
Centerpoint Energy is committed to reducing our emissions attributable to natural gas usage within the residential and commercial sectors by 20 to 30% by 2040.
Centerpoint Energy is committed to a 70% reduction in operational emissions by 2035.
Dominion Energy is working hard to achieve net zero greenhouse gas emissions across all our electric and gas operations by 2050.
NiSource has committed to a 90% reduction in greenhouse gas emissions by 2030 and a complete elimination of coal-fired generation by 2028.
The New York Power Authority is committed to helping New York State achieve 100% zero-emission electricity by 2040.
I'm Jeff Burleson, Senior Vice President of Environmental and System Planning for Southern Company. Back in 2020, Southern Company committed to a goal of achieving net zero greenhouse gas emissions by the year 2050. We also set an intermediate goal to cut in half our greenhouse gas emissions by the year 2030.
TVA has firm plans in place to reduce carbon 70% from the 2005 levels, and we look forward to developing additional solutions that will help us reduce beyond that 70% in the years to come.
Xcel Energy is leading the clean energy transition as the first major U.S. power provider to announce a vision of delivering 100% carbon-free electricity to our customers by 2050, with an interim goal of cutting carbon emissions 80% by 2030.
By 2050, Duke Energy plans to achieve net zero carbon emissions. It's ambitious, but we're well on our way. Since 2005, we've exceeded expectations and lowered our carbon emissions by 39%. We've accelerated our timeline to retire coal plants, expanded our renewables portfolio, and we're on a mission to do more. We're a clean energy leader, and will do our part to tackle the challenges of climate change. By generating cleaner energy, modernizing the electric grid, and building a future that creates value for our customers, our communities, and our shareholders.
Imagine a world with 100% clean energy. We are. That's why we're committed to 100% carbon-free electricity by 2050. To reach our vision, we will eliminate the use of coal, add more solar with storage to harness Arizona's sunshine, and continue to invest in vital carbon-free resources. It's a bold vision that will take all of us to achieve. Together, we can create a clean energy future.
We're at Garland Solar facility today near Bakersfield, California. My name is Jeff Burleson. I'm Senior Vice President of Environmental and System Planning at Southern Company. In my role with the company, I actually have the opportunity to sort of oversee and lead our net zero strategy, as well as our long-term generation planning and generation development. In May of 2020, Southern Company set an ambitious goal to achieve net zero greenhouse gas emissions by the year 2050. What that means is the company is going to do all we can to reduce our direct emissions of greenhouse gas. Net zero in terms of greenhouse gas emissions is really important for not just our company, but for the overall U.S. and the world in and of itself. Ultimately, the intent here is to try to limit global temperature rise. The objective is to try to keep it from a net zero standpoint to 1.5 degrees C or less. We've already made a lot of progress towards our greenhouse gas reduction efforts. In fact, through 2019, we had reduced greenhouse gas emissions by 44%. And through the end of the year 2020, we've reduced greenhouse gas emissions by more than 50%. And that's compared to our baseline year for greenhouse gas emissions, which is 2007. Our 2050 goal is a very ambitious goal, and it's going to take a concerted effort. For us to be able to achieve net zero emissions, what we're going to have to do, obviously, is to continue to transition our generation fleet towards low and no emitting generation resources. We're also going to have to continue to reduce the carbon impact of our natural gas business. Solar is going to play a big role for us in achieving our net zero goal. Particularly in the Southeast, where our regulated utilities are, solar is our best resource. But of course, in other parts of the country, wind plays a big part as well. So we're not only trying to drive improvements and lower greenhouse gas emissions in our southeastern states, we're trying to help the entire economy and the rest of the United States do that. And we're going to have a focused effort on technologies that really will sustain and enable us to achieve net zero. Those technologies would include things like long duration energy storage. They would include energy efficiency technologies, carbon capture and sequestration, advanced nuclear, electric vehicles. We've got to ensure that we get strong proliferation of electric vehicles. It's going to take all of those things working together in order for us to be able to achieve net zero overall. Once you get to high penetrations of either solar or wind generation, you need some energy storage to really back that up. And battery storage is a good short and intermediate duration storage technology to be able to do that. Energy storage is going to be an enabler to allow us to integrate in large amounts of solar and wind into the overall generation mix. And in addition to that, negative carbon solutions, planting trees or other things like that, biomass generation with carbon capture and sequestration, or direct air capture, some technologies like that. So this is an ambitious goal to get to net zero by 2050, but we've already got a great start. One of the nice things is that Southern Company has been able to reduce greenhouse gas emissions thus far without any mandates. We've been able to do it because of the economics of retiring some of our coal plants, implementing solar, implementing energy storage, implementing wind. Those things are cost effective for our customers, and with the right research and development focus, we'll be able to drive down the cost of those other low and no carbon resources to the point where we'll be able to achieve net zero in an affordable and reliable way for our customers.
By 2050, Duke Energy plans to achieve net zero carbon emissions. It's ambitious, but we're well on our way. Since 2005, we've exceeded expectations and lowered our carbon emissions by 39%. We've accelerated our timeline to retire coal plants, expanded our renewables portfolio, and we're on a mission to do more. We're a clean energy leader, and will do our part to tackle the challenges of climate change. By generating cleaner energy, modernizing the electric grid, and building a future that creates value for our customers, our communities, and our shareholders.
Imagine a world with 100% clean energy. We are. That's why we're committed to 100% carbon-free electricity by 2050. To reach our vision, we will eliminate the use of coal, add more solar with storage to harness Arizona's sunshine, and continue to invest in vital carbon-free resources. It's a bold vision that will take all of us to achieve. Together, we can create a clean energy future.
Welcome to the Low Carbon Resource Initiative's Unpacking the Research Vision virtual event. I'm David Bauer, President and Chief Executive Officer of National Fuel Gas Company. National Fuel has an over 100-year history of safely and reliably operating across the natural gas value chain, with a continued focus on the long-term sustainability of our operations. We're proud to be one of 40 industry sponsors of this important initiative to accelerate low-carbon technologies. The LCRI is jointly led by the Electric Power Research Institute and Gas Technology Institute. Today's discussion around the LCRI research vision will focus on three main areas: the motivation for the initiative, the research questions that address the initiative's focus areas, and the preliminary research plans aimed at advancing critical technologies. It's my pleasure to introduce the leaders of today's event: Jeffrey Preece, Senior Program Manager of Advanced Generation and Low Carbon Resources at Lcri, and Christine Wiley, Executive Director of the Hydrogen Technology Center at GTI.
Thank you, David, for that introduction. We're thrilled to have National Fuel Gas as a sponsor of the Low Carbon Resources Initiative. Hopefully, all of you were able to tune in yesterday to your discussion around the collaboration between Lcri, GTI, and our 40 industry sponsors. This initiative is a 5-year effort to accelerate and deploy low-carbon technologies. The LCRI is targeting advances in the production, distribution, and application of low-carbon alternative energy carriers and the cross-cutting technologies that enable their integration at scale. These energy carriers, which include hydrogen, ammonia, synthetic fuels, and biofuels, are needed to enable affordable pathways to achieve deep carbon reductions across the energy economy. The LCRI research vision lays out 8 areas where research and development will be focused as part of this unique collaboration spanning the electric and gas industries. Today's event will unpack these research areas, and we'll hear from perspectives on hydrogen and other energy carriers from an esteemed panel of guests. As we get started, please note that on the right of your screen is a panel for Q&A, sharing of ideas, and poll questions we will be asking throughout the event. So please engage with us throughout the session. It is my pleasure to now turn it over to Christine Wiley for more on LCRI's collaborative approach.
Thank you, Jeffrey. As premier R&D organizations, Lcri and GTI bring unique perspectives to the discussions around low-carbon resources and how to meet ambitious targets being set around the world. Our research vision represents over a year of work between both organizations, our sponsors, and our technical collaboration network. This network provides an opportunity for those in the global research community to exchange with and inform the membership through a series of technical exchanges, as well as through formal and informal technology transfer. Throughout today's event, you will hear our sponsors about the goals that they've set and how LCRI is an important aspect of reaching those targets. So to kick us off, here's a message from Trey Kuchar of Centerpoint Energy.
Centerpoint Energy is committed to leading by example and promoting cleaner air in our communities. We have and will continue to take significant steps to reduce carbon emissions. To this end, Centerpoint Energy is proud to partner with Lcri's Low Carbon Resource Initiative. LCRI provides a powerful platform for research, development, and activities to support economy-wide decarbonization by mid-century.
By collaborating with our partners and other utilities, we are developing a direct path to a cleaner environment, utilizing new technologies, and expediting New York's ambitious climate leadership targets. This effort is another great example of NYPA aggressively pursuing a low to zero carbon emission future for New York State. Our decarbonization strategy is designed to enhance New York's thriving economy and create a blueprint for others to follow.
Hello, and thank you for taking time to learn more about Alliant Energy's clean energy vision. In 2020, Alliant Energy set an aspirational goal to achieve net zero carbon dioxide emissions by 2050 from the energy we generate. This is part of our clean energy vision and is guided by our values to make things better and think beyond, be bold. as well as our purpose-driven strategy to serve customers and build strong communities. Striving for net zero carbon dioxide emissions depends upon the exploration of opportunities to remove carbon dioxide emissions resulting from our operational activities. It also means increasing our focus on partnerships with our customers, communities, regulators, and stakeholders in order to successfully progress toward achieving our goal and creating clean, reliable, affordable, and safe energy. We will achieve its success through technological advancements and conversion to a high percentage of carbon-free energy resources, much of which we expect to leverage with our engagement in the Low Carbon Research Initiative. Learn more about our clean energy vision, clean energy blueprint, and sustainability activities by viewing our corporate responsibility report.
It's time to start unpacking the research vision. As mentioned earlier, the 8 research areas were identified through feedback we received from our sponsors, along with experts and stakeholders in the global community. We also conducted a broad landscape analysis of deep decarbonization strategies. What came out of this effort are the following areas, which relate to the production and supply of alternative energy carriers, storage and delivery of energy carriers and fuels, and in-use applications. We're going to start with the integrated energy system analysis, which will evaluate pathways to deep carbon reductions and also guide our research plans across the initiative. The Lcri team is using an integrated energy economy model to evaluate the deployment of low carbon options and the impacts of the low carbon transition on energy usage, the economy, the environment, and consumers. We are incorporating technology cost and performance data from research conducted by the Lcri and also from experts around the world. The model contains energy supply and demand functions to study a variety of pathways to achieve deep carbon reductions. Multiple scenarios and sensitivities will be studied, with a primary focus on net zero economy-wide greenhouse gas emissions by 2050. Consumer perspectives are a critical element to the Lcri research vision. I'll turn it over to Christine to explain our approach for end-use applications.
So as Jeffrey has highlighted, we are evaluating multiple pathways to achieve deep decarbonization in all sectors of the economy. So while clean power generation is critical to achieving net zero goals, we must also address how to reduce emissions from transportation, industry, and buildings, which together accounts for more than half of global energy-related CO2 emissions. To make meaningful progress in the transportation sector, we need to evaluate how alternative energy carriers such as hydrogen can enable deep carbon reductions in various forms of transportation, both for on-road applications such as heavy-duty vehicles, as well as non-road applications such as rail and marine. A couple key research questions that we will address include: which alternate energy carriers will be embraced by manufacturers and end users, and what training, workforce development, and customer education needs will enable widespread adoption? Fueling infrastructure will also be critically important for transportation, so understanding the cost and deployment of alternative fueling stations will also be assessed. Moving on to the industrial sector, there are great opportunities to decarbonize processes in this sector, from developing low carbon feedstocks such as green hydrogen to decarbonizing process heat applications. The industrial sector also affords opportunities for carbon capture, especially in cases where you have a highly concentrated CO2 stream. So as we evaluate the use of alternative energy carriers in this sector, we will also need to pay close attention to any potential environmental concerns from the production and combustion of hydrogen, ammonia, or other low carbon alternative fuels. Environmental considerations include assessing any potential increases in NOx emissions, for example, and we'll also want to assess the relative effectiveness of potential mitigation technologies such as CCS, catalytic abatement, or scrubbing. The industrial sector is also very regional, so we'll need to assess what is the regional demand for these alternative energy carriers based on current and future projected geographic concentrations of specific industries. So buildings is the final sector I will cover, and this includes commercial and residential. The direct application of these alternate energy carriers in residential and commercial buildings is being explored to reduce the carbon intensity of existing natural gas end uses. These alternative fuel-based pathways could play an important role in decarbonizing building applications where space conditioning and water heating is more difficult or costly to electrify, such as in regions with older building stocks or sharp winter heating load peaks. RNG and synthetic natural gas or synthetic methane could also be injected into natural gas pipelines to reduce the carbon intensity of natural gas end uses. So now let's go to Jeffrey to talk about another key sector, power generation.
As the deployment of variable renewable power generation assets such as wind and solar PV grows, the LCRI plans to evaluate the need and use cases for base load and flexible generating resources. The Power Generation Research Area considers the trade-offs between alternative energy carriers and hydrocarbon-based fuels with carbon capture and storage. Some of the key technology options capable of supporting a clean electricity grid include gas turbines, heat recovery steam generators, boilers, reciprocating internal combustion engines, and fuel cells operating on low-carbon fuels. In addition to the trade-offs with CCS, this research area focuses on the use of low-carbon fuels, either blended with hydrocarbon-based or used as a pure fuel in existing power generation assets. We are also focused on the potential roles of new generation technologies, which could be designed to utilize pure low-carbon fuels. Back to Christine to present on the hydrocarbon-based processes and renewable fuels research areas.
So now we'll transition to the production of low-carbon fuels, which includes the hydrocarbon-based processes and renewable fuels. So currently, approximately 78% of the world's primary energy is supplied by fossil fuels. So with respect to hydrocarbon-based processes, we will focus on evaluating and advancing technologies in the following areas: production of low-carbon energy carriers from hydrocarbons, processes for being able to convert hydrogen to other hydrogen-based fuels such as ammonia, conversion of CO2 to fuels, and CCS from industrial sources, as well as from the atmosphere, more specifically direct air capture technologies. In the renewable fuels area, we will focus on solid and waste renewable biogenic feedstocks. We'll pursue research related to feedstock supply, production, conversion technologies for RNG, for example, biofuels such as ethanol, methanol, or even hydrocarbon drop-in fuels. In particular, in this area, some specific research questions we will address include what types and quantities of renewable fuel feedstock supplies are available, and what are some of the potential implications, whether environmental, social, or economic, of producing these feedstocks. And we'll also assess the options for handling feedstocks, such as treatment, upgrading, storage, and transportation, and how they might affect the renewable fuel supply. One key challenge associated with alternative energy carriers, despite the conversion technology or feedstock use, is the cost of production. So this will be a focus area of our research. This translates into understanding the techno-economic potential of displacing existing fossil fuel supply with low-carbon chemicals and fuels produced from low-carbon hydrogen or CO2 captured from industrial processes or the atmosphere, as well as other biomass feedstocks. So we need to evaluate various technologies and conversion pathways. And we already have an initial set of projects supporting the development of low-cost, low-carbon production of hydrogen, as well as assessing feedstock supply and emissions reduction potential of biofuels. So Jeffrey will now cover another key area in the production of low-carbon fuels, which uses electrolytic processes.
For electrolysis, we are considering the type, sizing, and configuration of specific technologies, the subsystems they require to operate, and how the operation of electrolyzers is impacted by upstream and downstream components of the alternative energy carrier value chain. Looking upstream to the electricity grid or other energy resources such as wind, solar, hydro, or nuclear, we plan to evaluate and model impacts on performance and reliability under dynamic conditions. To generate deeper understanding, we will incorporate integrated system modeling, which will involve simulations and demonstrations. Looking downstream, we are considering the impacts of various hydrogen use scenarios and the roles electrolyzer systems could play in meeting energy demand. We recognize there are different requirements when using hydrogen for combustion or heating, or as a feedstock for synfuels or ammonia production. Our research aims to characterize these scenarios to better understand system-wide impacts. How and when alternative energy carrier production supports the energy economy more broadly may depend on the availability of delivery and storage infrastructure. Christine will now walk us through this research area.
So we've discussed both the production and the end use of low carbon resources. And just as important is the delivery and storage infrastructure needed to support these resources. How do we get these alternative energy carriers to the end users in an affordable, reliable, and resilient manner? So the vision of what the storage and delivery system looks like and its optimal configuration, such as production and supply being centralized or decentralized, depends on the future energy mix. However, leveraging the existing energy infrastructure to enable the use of these alternate energy carriers provides a tremendous opportunity that could prove economical and reduce barriers to broad-scale adoption. In this area, we will look at issues such as how the storage and delivery system may need to adapt and evolve to meet consumer demands and expectations, and what large-scale energy storage options are being developed. For example, hydrogen offers a solution for large-scale seasonal storage needed to address the intermittency of renewables. However, that won't come without challenge. There are many efforts focused on pipeline hydrogen blending in countries such as the High Deploy project in the UK, as well as some efforts here in the US with a handful of gas utilities, so we can leverage these collective efforts. But we also have a massive underground storage infrastructure that can be utilized, which can benefit from increased attention and R&D investment. For hydrogen, ammonia, biofuels, or synthetic fuels, we need to assess a number of impacts that range from fuel monitoring, metering, codes and standards, retrofitting challenges, and impacts on materials of construction and even leak detection. And so with all of our research areas, environmental and safety impacts will be very important factors to consider as well. So I'll hand it over to Jeffrey to discuss some of these in more detail.
In addition to carbon reduction potential, the LCRI is examining other environmental aspects which could address air quality, water usage and consumption, and water quality as a few examples. The location and scale of deploying alternative energy carriers will play important roles in defining the impacts from regulatory compliance and reporting requirements. Over the course of the initiative, we intend to address metrics and aspects of lifecycle analyses for the use of alternative energy carriers. With many emerging applications, LCRI plans to evaluate the potential increased risk to personnel safety as systems are scaled up and deployed. Protocols, procedures, codes, standards, and training related to the operation of new technology applications will be critical for safe deployment. It is of paramount importance that we address the transition to a low-carbon energy economy in ways that provide safe, affordable, reliable, and environmentally responsible energy for everyone. There is so much more to unpack in the LCRI research vision. We invite you to read through our materials and send us your feedback. Coming up, we'll be joined by a panel of guests to talk about demonstration projects and their importance in commercializing technologies.
APS's clean energy commitment to provide 100% clean electricity for our customers by 2050 is focused on achieving environmental and economic gains through collaboration. All of this while maintaining a safe, affordable, and reliable grid for the benefit of our customers. Like many other utilities, our goal relies heavily on technology and capabilities that are not yet widely adopted or even commercially available yet today. By bridging the common goals of the industry through collaboration, shared investment, LCRI allows us to leverage utility-wide investments to drive down the overall cost of research in new and clean technologies for all of our customers. The LCRI also ensures a clear roadmap for a clean energy future with a better understanding of the different technologies and pathways to achieve 100% clean electricity. We're embarking on uncharted territory with our clean energy commitment, and we know that we can't achieve it alone. With close alignment and support of each other across the industry, we can uncover solutions to our goals that ensure safe, affordable, and reliable service for all of our customers as we collectively transition to a cleaner future. On behalf of APS, we are proud to be a member of EPRI's LCRI.
As an innovation leader, TVA is supplying clean energy to the people of the Valley, and we are developing the energy system of the future. We understand the need to rethink the carbon problem, and it requires a collaborative solution of working with others in the industry. That is why TVA, in conjunction with EPRI, the Gas Technology Institute, and other utilities across the nation, are participating in the Low Carbon Resource Initiative, which is essential for solving these problems. TVA has firm plans in place to reduce carbon 70% from the 2005 levels, and we look forward to developing additional solutions that will help us reduce beyond that 70% in the years to come. By collaborating with partners in this industry initiative, we are now looking at what is achievable beyond 2030. Almost 90 years ago, TVA utilized hydropower to provide electricity for people of the valley to make their lives better. Today, TVA is honored to be a partner in the Low Carbon Resource Initiative to evaluate technologies such as carbon capture, advanced nuclear, and hydrogen to continue our mission of making life better for the people of the valley and those that we serve.
Jeffrey and I are very excited to be moderating this panel today. Our panelists will be sharing their efforts on various low-carbon technology pilot and demonstration projects. We will hear from 4 of our LCRI members today: Yuri Friedman from SoCalGas, Paul Tartaglia from NYPA, Jeremy Koster from Duke Energy, and then Jim Duell from Black & Veatch. So let's start with Yuri Friedman from SoCalGas. Yuri is the Senior Director of Business Development at SoCal, where he manages the portfolio of growth initiatives and R&D activities for the company. So Yuri, SoCal has set a bold commitment, net zero by 2045. And I've had the pleasure of working with SoCal for many years now, and you've always been a leader in the clean energy space. So it's not surprising that you would also be leading the way in hydrogen and CCUS. You've led several key pilot projects and announced some exciting new initiatives around hydrogen. So today, can you share some of your recent efforts in this space and maybe talk about some of the gaps that SoCal has identified and the role that LCRI could play in addressing some of those needs?
Christine, thank you so much for the introduction and thank you for the opportunity. Good morning, afternoon, or evening, depending where you are in the world. And Christine, before I address the specific questions about demonstration projects we're working on, I'd like to make some remarks about the important nature of LCRI and why I think this particular collaboration is so important today. In our view of energy system at SoCalGas, they have to be safe and reliable. This is foundational. And as we move forward, making the systems increasingly environment friendly, we also have to maintain their affordability. But there is one aspect of the systems that I think is of overarching importance in the context of energy transition, and this is the integrated nature of the energy systems. What I'm referring to is the fact that clean electrons and clean molecules have to work together to deliver all attributes of energy system I just mentioned. In fact, Bloomberg New Energy Finance estimates that contribution of electrons and molecules to global energy demand in 2050, if we were to meet the 1.5 degrees Celsius global warming limit, is about equal. What does it mean for utilities, for electric and gas utilities? It means that we have to work together and develop new technologies on both electrons and molecules fronts. It means for us in California, where the state is aspiring to continue its role as a leader in technology laboratory for the country and the world, that we should be developing these integrated energy systems that work not only here in California, but can be deployed nationwide and ultimately globally, scaling up and bringing down the cost of what Bill Gates calls a green premium, higher costs of green technologies compared to carbon-intensive alternatives. And I think that to succeed in our global climate change efforts, we have to make these technologies affordable worldwide, and in particular for the developing world, in order for these countries to join us in global emission reduction effort while addressing their growing energy demand needs. So the critical nature of integration of electrons and molecules is why I think LCRI is so incredibly important as a truly groundbreaking large-scale joint electric and gas industry technology initiative. As the largest North American gas utility and as the company that just made its own commitment to carbon neutrality by 2045, we are truly proud to be its participants and look forward to work ahead. Now, this work for us will entail growing our portfolio of research, development, and demonstration technologies. And as you mentioned, we have projects in the works that are going to explore various pathways of green, blue, turquoise, and many other colors of hydrogen. We're going to carefully look at the potential of carbon capture and sequestration. We are working and will do more work on such technologies as fuel cells, which can combine increasingly clean environmental footprint and high resiliency, which is becoming really important in the context of the challenges we're facing today, not just climate change, but the issues such as wildfires and other power supply challenges. So I really look forward to working across the gas industry and even more importantly with our electric industry colleagues to together explore these alternatives and to bring them to ultimately global scalability. Thank you.
Thank you, Yuri. We'll turn now to Paul Tartaglia. Paul is Senior Vice President and Chief Technology and Innovation Officer at NYPA. Paul, we know that NYPA has launched its Vision 2030 plan, which outlines strategic priorities for the organization in conjunction with the state of New York. Tell us about your perspectives on the role of demonstrating technologies to support these plans. And Paul, we might need to check that your mute is not on.
Okay, so much for all the rehearsing we did. Thanks for having me today. First I'd just like to lead a little bit off with NYPA. For those of you not familiar with the New York Power Authority, we were established in 1931 by then New York State Governor FDR. FDR took that very same model with him to DC as president to develop the TVA and public power across the United States. We have about 2,400 employees across the entire state. We run 1,400 miles of high voltage transmission, about 1/3 of the high voltage transmission system in the state. We have 16 generating facilities, both hydro and natural gas, that represents about 6 gigawatts of electric production. That's about 25% of the normal load in New York State. About 75% of the power we produce is actually produced from hydro-based resources. A trivia question for future use is we also are the operator of the Erie Canal system. Basically connection between the Hudson River and the Great Lakes, but we'll save that for another day. The authority sustains almost 400,000 jobs through economic development across the state, and we invest almost $250 million a year in energy efficiency projects, which is really important for us to get to this low carbon future. As well as being one of the first members of LCRI, we're active members in EPRI for over 30 years. We're also very active members in a number of other research organizations such as CIATI and the National Offshore Wind Research and Development Consortium. I'm really proud to say that NYPA hasn't been a Johnny-come-lately to low-carbon resources. As far back as 2006, we completed a demonstration project working with EPRI, burning biofuels, a 900-megawatt boiler with a blend of almost 20%. Anyone interested in it, you can go to EPRI or you can just simply Google NYPA biofuel and you'll see some of the research and some of the fine work we did almost 2 decades ago leading to low carbon. Those of you familiar with New York State in general, we have some of the most ambitious carbon reduction goals, not just in the US, but you can argue globally. Our objectives, based on the Climate Leadership and Community Protection Act, also CLAPA, is an 85% reduction in greenhouse emissions by 2050, 100% zero emissions electric by 2040, 70% renewable energy across the state by 2030, 9,000 megawatts of offshore wind by 2035, 3,000 megawatts of energy storage by 2030, and 6,000 megawatts of solar by 2025, as well as a commitment to remove over 20 million tons of carbon at our customer sites. So to help achieve that goal, the Power Authority's put together a 10-year strategic plan. NYPA Vision 2030 has 5 key pillars. 4 of them are purely focused around decarbonization. First pillar, decarbonize natural gas. Obviously, that's one of the things that brings us all here today. So we're working towards pioneering the path to decarbonization. Decarbonize our customers. So much like Christine noted earlier, it's not just the electric generation, but it's those other end users. Home heating, transportation, and the other sectors of the economy that actually represent equal to or greater carbon issues as the electric generating sector. We have another very important feature, we believe, and I appreciate the discussion about energy carriers, but expanding our transmission system. We recognize that in the world of the future, energy flows are going to be very different in those energy carriers. One of those is our high voltage transmission system, which we will see very different use as it is today as will be in the future. And then to preserve and enhance our hydropower, which is ultimately, the cornerstone of New York State's very low emissions rates and will continue to be until we develop these alternate energy carriers. So the role of demonstrating tech, really very simple. NYPA's always had a reputation of doing, leading. We intend to fully continue to lead to achieve these goals. But my personal opinion is, as of right now, there is no silver bullet. If you look at this country, the vastness of this country, the diversity of this country, the diversity of the resources, both geographical, geological, wind resources, solar resources, there is no silver bullet. And we really have to have a multifaceted research effort now to get to where we want to be in 2050. So, the concern here is there is no one-size-fits-all, and we're very anxious to help demonstrate those technologies that are most suitable for New York State to achieve its goals of a low-carbon, zero-carbon future.
Great. Thank you so much, Paul. It's so great to hear that you've already been actively deploying low carbon technologies and that you're keeping the customer front of mind and really open to having flexible and optionality in terms of solutions. So now let's hear from Jeremy Koster from Duke Energy, who leads the transformation and sustainment team in Duke's natural gas business unit. So Jeremy, thank you so much for joining us today. I've been very fortunate to be able to work with Duke in a number of areas focused around decarbonization, looking at RNG and your efforts around reducing methane emissions from your own operations. So we know that Duke's gas business has a net zero methane emissions target by 2030, which is part of the company's overall target to achieve net zero carbon by 2050. So can you tell us a little bit about these plans and how demonstrations plays a role in them?
Yeah, absolutely, Christine. And first, I just want to say I'm humbled and honored to represent LCRI, Duke Energy, and really our industry and the customers within it on this very purposeful panel. So yeah, you're exactly right. We have a stated enterprise goal at Duke Energy of a net zero of CO2 by 2050. And really to complement that in the natural gas business unit, we have a net methane goal of a net zero by 2030. So what's that look like for us? There's really 6 work streams that is in the portfolio today, and that can change as technology and processes change, certainly in the U.S. and the world. But really, there's a methane reduction effort going on. There's a customer component where we're working with tariffs with our customers. There's downstream and upstream, really targeted towards Scope 3 emissions to get that better for really the planet, if you will. And then the last 2, really RNG and hydrogen. And I want to speak to both of those because we're doing some unique things with both inside the natural gas business unit as well as in the larger enterprise. And I'll start with RNG. I think we're in a very unique position where maybe for once in our lifetimes, us as utilities, companies, businesses, the goals we have around climate are almost identical, and if not very similar, to just about everybody that we're around today. And that's a really unique position to be in because we're really aligned to what we're trying to achieve, and that's really a net zero carbon by some kind of time frame that we've all stated. And we see RNG as a big part of that, at least for the natural gas business unit, probably one of the largest ones. And so municipalities are in that population, and we are part ownership in a Sustain RNG, which is primarily in the cattle feedstock, and there's others that RNG is in that sector. But really wastewater is one that really, both from a utility perspective and from a commercial perspective, have a really good opportunity. And what we're seeing happen is we're being asked, the cities and the local municipalities, they have their own sustainability goals. And any more flaring or exhausting methane in the atmosphere is not an option to really meet those goals. And that's where we kind of come into play. they're also not pipeline operators, so it's not their core business. And so we're working with a couple local municipalities where we take that digester gas, off the scrubber and build a conduit, if you will, to directly inject that back into the pipeline. And then the municipality can completely eliminate their flaring or exhausting in the atmosphere, and that's good for them, and that's good for us, and it's good for our customer at the end of the pipe. The other one I want to talk about that's a little bit outside of our natural gas business unit as a whole, but that's our project and demo we have with Siemens and Clemson University. And for our Clemson fans out there, that's affectionately known as H2 Orange, and you can look that up out there and see really some in the weeds information. But at its core, we're really taking their existing combined heat and power situation, and we're going to fire that existing turbine with a stored hydrogen component. And we're going to produce that by an on-site electrolyzer to really store the hydrogen and then fuel the turbine for their energy needs on the campus. And so currently we're in DOE research to really see, okay, what's the component of hydrogen we can put onto that turbine to really get to as close to 100% of a burn as we possibly can on that turbine. And so we're really proud of that demo for a couple reasons. It's one, not only is it demonstrating innovation in front edge technology, but it's also helping one of our own customers, which is a key priority of ours to really, power the lives of our customers and the communities in which we serve. And so, and I think also, what a better place to do a demo like that, where we can demonstrate front edge technology with the very emerging workforce that we're trying to attract within our industry. So we're really big on that, and we're up and rolling on the research that as we speak. So again, thanks for having me today, and look forward to the conversation.
Thanks, Jeremy. And I like your examples because they touch on, as does the LCRI research vision, the role of today's technologies in enabling this path to decarbonization. We're not starting from scratch. We're not starting from new. And so the importance of how today's existing assets and customer demands interact with this transition and low carbon future is obviously going to be important. So thanks for sharing those details. We're going to turn now to Jim Duell, who's an executive vice president at Black & Veatch. Jim is a global engineering, procurement, consulting, construction company. Black & Veatch has many active projects worldwide, and your company is also very active in many areas related to the LCRI. It's also interesting to me that Black & Veatch has its own set of company sustainability goals and commitments that encompass a value chain approach, something that the LCRI is focused on. So what are examples of commercial demonstrations that you could point to important to have in this future?
Thank you, Jeffrey. And Black & Veatch is pleased to be a member of LCRI. We've been involved with EPRI for many, many years, and this is a great initiative to be a part of, to contribute to, and gain knowledge from. So thanks for having us. Black & Veatch has been in the sustainability business for many, many years, and it's embedded in our culture around our global business. Today, like never before, Black & Veatch influences and impacts sustainable development through our work and how we govern our own business and operations around the globe. We do have a net zero by 2025 for our operation, our facilities, and our professionals, and then that'll cover over to our projects as well. So it's exciting times. For those of us that have been in the generation business for quite some time, and having come through the gas bubble, the coal bubble, the back end bubble, and now the sustainability and decarb bubble, it's really exciting. To me personally, watching the solar over the last decade and the wind over the last decade was exciting and transitional, but looking forward to our future, it feels like it's accelerating, in my personal opinion, and it is. And LCRI is going to be pivotal in that, and we'll push it forward very quickly. So we're excited to be a part of it and enjoy the projects that we're doing. You asked about some projects, so I thought I would just give you kind of a smattering of the many projects we do around the world with our 10,000 employees. Right now, we've seen just a lot of studies and early entry investigations, and I'm proud to have worked with all the clients that are on the panel. Thank you for the business and for the work we do together. But right now, there's a lot of studies and feed work that are going on, and Black & Veatch is involved in many different areas. So I'll just give you just a little bit of examples. We're doing hydrogen filling stations now around the United States, starting out in California and down in Texas. We're doing increased ammonia production plants up in Ohio and up in the Northeast. This is to increase hydrogen production capacity and produce more ammonia. We're doing hydrogen tube trailer depots for companies up in the Northeast United States. We're doing studies for various hydrogen energy projects using integrated gasification, IGCC. That's been popular as well. And then we're also doing more ammonia production involved with hydrogen production as well. We've done coke gasification to hydrogen, methanol and carbon monoxide studies. And our flagship project that we're involved with now is the project out in Utah for a major client that's going to decommission coal and then sell hydrogen fueled generation to California. And we're pleased to say that their goal is to be 25% fired on combined cycle generation for a very, very large project that's fueled by green hydrogen. So it's a really exciting time in the industry. There's lots of things going on, kind of early development in our opinion, but lots of exciting things. So thanks for having me.
Great. Thank you so much, Jim. And it's so great to see the diversity of projects that you're working on. I think that's very in line with what we've been hearing from the other panelists, and that, we do need to have the flexibility to evaluate different pathways and different technologies. When we start looking towards that 2050 timeframe and being able to achieve net zero, scale is a really important part of the discussion when it comes to these technology demonstrations. So we're going to move more into a panel discussion here. And one of the first questions that I have that I'll direct towards Paul and Jim, if you don't mind providing your comments on this and perspective, is, what do you see as being some of the largest challenges that we'll need to overcome when launching some of these technology demonstrations?
So one of the largest challenges I see right now would be cost recovery. For these large demonstration projects. There's tremendous amount of risk associated with them. There's market uncertainty on long-term rate recovery or cost recovery of the different market designs that we have across the United States and globally. So I think these are all very good and very honorable projects, but some of them are going to be quite expensive and there's a lot of risk associated with it.
Yeah, I agree with you, Paul. I think that getting the projects to be economically viable is going to take a lot of cooperation across different parts of the industry. From our vantage point, we need regulation help, just like it's been provided in the past. That'll be a key component, and it needs to be there, and it needs to help the industry advance, just like it has in the renewable industry in the past. We believe that capital cost reductions have to come forward, and the industry has to do this. Just like it has in the solar business and some of the cost down structures for scale ups that we've seen in the past on these major projects. Without the reduction in supply chain, without the increased capacity of that supply chain, the projects won't get the cost reductions that will help them make them economically viable.
Great, thank you so much. Jeremy or Yuri, if you have any comments to add, please go ahead.
Yeah, I think the points, and we're hearing a trend from the panelists. I mean, I think in the supply chain, I'll use an example of cross recombustion where we're taking on a pipeline where instead of flaring that gas on a tie-in, we're putting that in a separate compression situation, and we're putting that back in the pipeline. When you look at the environmental premiums that are on some of the things that we have to do to achieve the goals we have to achieve, some of those costs, if they were your business, you would look at those and really think, if this were my business, would I really be making the decision to do this? So how do you fix that? And I think you're right on point. I mean, at the supply chain, really, you're in a chicken or the egg situation. I think it's going to take the people on this call, the people out there in the world, to really go to scale quickly on some of these items. Because I think the more we go to scale and make big bets on the things that we're doing inside of our systems, then that drives the supply chain down and it disperses old technology. So it's kind of a do or don't, and I would urge us to do, because that will drive the supply chain down, get our manufacturing in shape and in stride around delivering the products we need to do this work, and really make it more acceptable then to the regulatory bodies. So I think the more we do, the higher the faster the scale, the quicker the supply chain recovers, and it's already still recovering from the pandemic. So that just puts even compounds more pressure on top of it. So I really think scaling quickly will drive the supply chain, which will get those environmental premiums down. That probably makes a little more sense to make those bets.
I think we've got a couple lines muted. If our panelists are trying to speak, just a reminder.
Sorry about that. It was my turn to be muted. Christine, I agree with my fellow panelists. What I would like to add is that in my mind, there are 3 stages in which technology must pass in order to ultimately be adopted at scale. And I think LCRI is one of the critical steps to creating that first stage where technologies are proven to work, where we can work out the technological kinks and effectively bring it from the bench scale to the demonstration scale. I also know that we know the end vision. The end vision is the large utility systems which are going to be deployed at a scale commensurate with the size of all of our companies. I think to me the challenge is in traveling from this demonstration scale through the larger scale, if you will, pilots or first large commercial projects to scaling up. And I'm thinking about the example, the real world example that we in California have lived, and you all know, I've taken a look at the evolution of the costs of renewables. Unfortunately, there's publicly available chart, wonderful chart at Lawrence Berkeley lab site showing the cost of PV solar. This cost came down full order of magnitude in the space of 1 decade. Faster than anyone could have possibly foreseen, including myself, if you look what happened between 2008 and 2018, which is quite remarkable. And it's even more remarkable that large part of it happened because of what I think Paul and Jeremy mentioned is the scaling up. So it's not necessarily inventing something which is technologically innovative. It's doing something which we know how to do better, more efficiently, larger scale. So I think we know the recipe for that. The recipe for that is the policy action that is going to allow the capital to scale up and to build those larger projects. I think for the country and for the world ultimately to be successful, that policy action has to happen, whether it's executive or legislative. But I think that that's really important for that to happen. We obviously see these conversations taking place, in fact, today and yesterday at the federal level. But I do think that it's going to be a very important element of getting from demonstration scale to actual deployment of these technologies at the scale that
So I'd like to just jump back in and express my appreciation for the work through LCRI, through EPRI, through GTI, where you actually help the utilities de-risk some of these projects and these demonstration projects, both with some of the funding that you guys help us acquire, as well as sharing of best practices and technologies to help scale up faster with less risk. So really just an opportunity to express, at least for the Power Authority, our appreciation for this organization and the help you will ultimately provide us.
Well, thank you for that, Paul. So the LCRI is focused on further growing collaboration through the execution of this research vision and then future launch demonstration projects out of this initiative. So Jeremy, how important will other stakeholders be for the success of LCRI specific demonstrations?
Yeah, again, I'll follow on a trend that's been said on the panel already, and that's really the policy, and before that, the legislative work that needs to be done. Let's just face it. I really think if you're an operator or an local distribution company or a contractor on this call, we're world class at putting infrastructure in the ground and up in the air, and then taking that infrastructure and serving our customers in a very safe and reliable way. So I think we're world class at that. I really think that the legislative and the policies and those bodies have to move at pace of the demonstration. So how do you do that? I think if you don't have your policymakers and your internal legislative teams at the table at the very same time you're designing, doing your due diligence, talking about conceptualizing and then feasibility, then you're really missing an opportunity to get them grounded and be a tip of the spear in the effort. Because without that, you can design, the best situation that you possibly can that you can't put in the ground. And that's nothing more would be more frustrating than that. So I think that's what's going to take really to scale to what Yuri said. He's exactly right. It's going to have to be that legislative body. That arm has to be at pace with the demonstration. And I do want to also comment on what Paul said. I agree. If you look at our individual companies, not any one of our individual companies can execute on all of the different configurations that are possible in all of what we're talking about today. So this effort really allows us to try things, hundreds of things that we can then all take that research and put it all together and do something with. So I appreciate the effort, and it is groundbreaking to help get through the funding situation that we all face, today in doing these projects. So thank you.
Yuri, I'll ask the same question to you. How can we make sure that LCRI demonstrations will be successful?
Thank you for asking this question. I think there are two, well, there are many more than two, but I'll focus on two key, in my mind, pillars. One is what strikes me as we talk to our colleagues on both gas and electric sides in the country and globally is just how much work is being done. Because ultimately, let's face it, every utility in every location that has its climate goals is ultimately trying to solve very similar problems. Accounting for the enormous diversity of the resource, accounting for differences in geography, not to mention differences above ground, which is policy and politics, we all are ultimately trying to figure out the same thing. And so I think collaboration across industry in order to benefit from each other's advances is really crucial for it to be successful. And I hope and believe that LCRI can be one of the very important levers of accomplishing that. I will also go back and say that even on the policy front, what strikes me when I look at some of the events in Europe is that while we are talking about the need to scale up, they're actually scaling up. If you look at the goals that EU adopted to build out 40 gigawatts of electrolyzer capacity by 2030, and if you couple this with an even more remarkable fact that more than half of that is now spoken for in the member states' budgets, that is actually something that is going to happen on gigawatt scale. That's, in my firm opinion, what we need to happen here in order for us to be successful, not just, as Jeremy said, demonstration scale, but ultimately to make sure that people understand that continuity, that we're going from a research project to demonstration projects, then to larger scale. But our objective is to build low carbon energy system that will provide enormous amounts of energy. And that's scaling up, again, technology and policy. I completely agree with everything that was said by other panelists, have to work together, not just countrywide, but also, frankly, globally.
Great. Any other panelists?
I would agree with you, Yuri. I think the recent changes in the forecast for the hydrogen consumption or production that have been updated on a yearly basis just tell you that this industry is exploding. So if you look at Europe's build out spend and you look at Australia and Japan's buying and building spend, I mean, that tells us where the industry is going in other parts of the globe, and they're massive compared to what the United States has on our growth curve. So we're looking at the hydrogen explosion or the growth of that business to be tremendous, and we've got to be involved in that from either generation or transportation. It's in all different industries, and so we need collaboration between the suppliers, the distributors, the storage folks, and all the industries to help make this transition smooth and economical. Right now, we know what the price has to be to make all those industries work. and we're not there. So together with LCRI, the research and the setting of the targets, I think will help bring the numbers down to where it's economical for us.
So, Jim, you touched on the value chain approach here. And within LCRI, when we talk about these low carbon resources, whether it's hydrogen or ammonia or biofuels or synthetic fuels, we're addressing all parts of that value chain. So maybe given the diversity of projects that your company works on, what do you believe are some of the areas of that value chain and highlighted in LCRI's research vision that are most important for like early stage technology demonstrations?
That's a big question. So I don't know that I can answer with a simple answer, but I mean, in the research vision, what I really liked was in your early and mid and future perspectives, anybody can get comfortable with any part of that vision, and they can go into that and see projects that they can go and take in each section of those. We see a lot of clients, whether they be utilities, suppliers, or C&I industries that are coming to us saying, what should we do? Should we put battery storage in? Should we do renewables or offshore wind? Or will this hydrogen work? And so it's really exciting for us to be involved in that, providing solutions, helping them study what works for them. I don't know that there's a one size fits all. I know everybody needs to evaluate the various technologies. And I think the research vision helps us say, when you're in the early stages of planning your future for your organization, you should be considering these steps and these evaluations. If you're ready for a demonstration project, I think like someone said, should you scale it? We've had some demonstration projects that got halfway through the demonstration and they already saw the benefits and they scaled. And so companies are going to make different decisions along their own journeys. And I think the LCRI early, mid, and future pathways helps guide some of that.
Great, thanks. Any of the other panelists? Maybe Paul, I know you touched on the fact that you've already been deploying some technologies to help with decarbonization for your customers. So any thoughts on that, on some of the more important aspects associated with early stage technology demonstrations?
Oh, well, the technology demonstrations, I think we need to be focused on some of these very early stage technology demonstrations and proof of concept projects around stranded assets, or how we can preserve stranded assets. I mean, let's face it, if we had to redesign the energy system from a fresh piece of paper, it wouldn't look anything like it is today. But right now in the United States, there are trillions and trillions of dollars of assets deployed, whether it be pipeline or generating facilities or other technologies. So how do we get rapidly adaptation, but still manage to preserve those stranded assets?
Great. So, Yuri, did you want to add something?
Yeah, if I may add, I completely second Paul's view. And as we are going to manage this transition, again, the challenge of balancing environmental attributes and affordability, while of course maintaining safety and reliability, is going to be a large one. And there are reasons why past energy transitions took many more decades than what we are aspiring to execute. And the last one, as we know from Václav Smil's books, took sometimes centuries. We're aspiring to do ours in 20, 30 years. But what it really means is that we have to explore all ways of leveraging existing assets, which are, as Paul said, enormous. We have trillions of dollars. We have assets that, in fact, may be very hard, if not impossible, to build today. And repurposing these assets, I think, is super important, because I think if experience of the last several decades teaches us anything, it's the fact that typically existing, or as they say, brownfield infrastructure is typically cheaper than new one. We don't know the exact answer in this case, and the work is to be done, but I think exploring all possible ways in which we can use our production, transportation, storage, distribution, and use infrastructure for the new purposes, I think is going to be a very important element of work.
Great perspectives, Yuri. Appreciate you adding that. So with the remaining time that we have, I'd like to go around and allow you all another opportunity We've talked a lot about beyond demonstrations, some of the putting steel in the ground, looking at early stage technologies, designing, development, understanding that companies will make decisions based on their specific needs. But if we could go around and just any other specific considerations that you think are crucial to enable scale up, but also adoption of technology. So Jeremy, we'll start with you.
Yeah, thanks for the opportunity. I would say that as a leadership team on the call, I think there's also a lot of work to be done just in the general culture of our companies, right? What is possible, moving away from what we used to do over the last couple decades or so, and really have an open mind to try new things. And I'll give you a specific example. We're experimenting a lot with satellite imagery right now. And if you asked me, I was going to be pulling satellite captures on a monthly basis right now, 3-4 years ago, and using that for leak survey, then I could tell you I wouldn't get a lot of buy-in in the company. And we're starting to get traction around that. But that's an example of, all right, can you actually take a satellite image and use that as a part of the process to get to as close to real-time emission on your pipeline as you possibly can? And I can tell you the answer to that's yes, we're seeing that. We're not in scale on that, but I think it's going to take culture to have an innovative mindset, harvest and mine those ideas, and then put those to action as quickly as you possibly can with the ones that make sense that you can prioritize.
Great. Well, thanks to all of our panelists. We appreciate your leadership and your sponsorship of the LCRI. We're really excited to see all the great things that we're going to accomplish together. And thank you for attending and speaking today.
Thanks, everyone. It's been a great discussion.
Thank you.
The energy transition and the increasing commitments to net zero emissions have fundamentally affected our company and our strategy. The biggest challenges facing the power industry over the next 5 years, in my view, are related to decarbonization. The challenges kind of are around that, and what, more specifically they mean is advancing the technology of battery storage, for example, to turn renewable energy more into base-loaded energy sources. Also looking at other base-loaded energy sources and looking how those can be cleaner. So for thermal generation, for example, the introduction of hydrogen as a fuel brings in the ability to still have large-scale baseload power generation, but carbon-free.
I'm Jeff Burleson, Senior Vice President of Environmental and System Planning for Southern Company. Back in 2020, Southern Company committed to a goal of achieving net zero greenhouse gas emissions by the year 2050. We also set an intermediate goal to cut in half our greenhouse gas emissions by the year 2030. I'm incredibly proud of the progress we've made, reducing our greenhouse gas emissions by 34% through the year 2018, by 44% through 2019, and now 52% through the year 2020. Research and development is critical to our ability to decarbonize both the energy system and the economy as a whole, while achieving our primary mission to reliably and affordably serve the customers and the communities who rely on us every day.
Thank you for joining our session today, and a special thanks to our sponsors and guests who joined the event. We hope that you've enjoyed and were inspired by the events, and encourage you again to go read through our research vision and send us your feedback. Christine, I'm really looking forward to what this initiative is going to cover in the next 5 years.
Thanks so much, Jeffrey, and thank you to the audience for participating. We look forward to further engagement with you all.
Hello, and great to talk with you again. I'm Pedro Pizarro, President and CEO of Edison International, the parent company of Southern California Edison and Edison Energy. It has been my pleasure to serve on the EPRI Board Working Group for the Low Carbon Resources Initiative. As you've heard over the last 2 days, there is real urgency around deploying technologies that will be needed to reach net zero. Today's discussion around commercializing those technologies through demonstration projects is a central focus of our initiative, and it's an initiative that will have a lasting impact around the world. We've enjoyed interacting with you, and we look forward to continuing this important conversation. If you would like more information and resources, please visit lowcarbonlcri.com and follow the Twitter handle @lowcarbonlcri. Thank you, and please be safe and healthy.
We're at Garland Solar facility today near Bakersfield, California. My name is Jeff Burleson. I'm Senior Vice President of Environmental and System Planning at Southern Company. In my role with the company, I actually have the opportunity to sort of oversee and lead our net zero strategy, as well as our long-term generation planning and generation development. In May of 2020, Southern Company set an ambitious goal to achieve net zero greenhouse gas emissions by the year 2050. What that means is the company's going to do all we can to reduce our direct emissions of greenhouse gas. Net zero in terms of greenhouse gas emissions is really important for not just our company, but for the overall U.S. and the world in and of itself. Ultimately, the intent here is to try to limit global temperature rise. The objective is to try to keep it from a net zero standpoint to 1.5 degrees C or less. We've already made a lot of progress towards our greenhouse gas reduction efforts. In fact, through 2019, we had reduced greenhouse gas emissions by 44%. And through the end of the year 2020, we've reduced greenhouse gas emissions by more than 50%. And that's compared to our baseline year for greenhouse gas emissions, which is 2007. Our 2050 goal is a very ambitious goal, and it's going to take a concerted effort. For us to be able to achieve net zero emissions, what we're going to have to do, obviously, is to continue to transition our generation fleet towards low and no emitting generation resources. We're also going to have to continue to reduce the carbon impact of our natural gas business. Solar is going to play a big role for us in achieving our net zero goal. Particularly in the Southeast, where our regulated utilities are, solar is our best resource. But of course, in other parts of the country, wind plays a big part as well. So we're not only trying to drive improvements and lower greenhouse gas emissions in our southeastern states, we're trying to help the entire economy and the rest of the United States do that. And we're going to have a focused effort on technologies that really will sustain and enable us to achieve net zero. Those technologies would include things like long duration energy storage. They would include energy efficiency technologies, carbon capture and sequestration, advanced nuclear, electric vehicles. We've got to ensure that we get strong proliferation of electric vehicles. It's going to take all of those things working together in order for us to be able to achieve net zero overall. Once you get to high penetrations of either solar or wind generation, you need some energy storage to really back that up. And battery storage is a good short and intermediate duration storage technology to be able to do that. Energy storage is going to be an enabler to allow us to integrate in large amounts of solar and wind into the overall generation mix. And in addition to that, negative carbon solutions, planting trees or other things like that, biomass generation with carbon capture and sequestration, or direct air capture, some technologies like that. So this is an ambitious goal to get to net zero by 2050, but we've already got a great start. One of the nice things is that Southern Company has been able to reduce greenhouse gas emissions thus far without any mandates. We've been able to do it because of the economics of retiring some of our coal plants, implementing solar, implementing energy storage, implementing wind. Those things are cost effective for our customers, and with the right research and development focus, we'll be able to drive down the cost of those other low and no carbon resources to the point where we'll be able to achieve net zero in an affordable and reliable way for our customers.
In 2020, Alliant Energy set an aspirational goal to achieve net zero carbon dioxide emissions by 2050 from the energy we generate.
In January of 2020, APS set a bold goal to provide 100% clean, carbon-free electricity to our customers by the year 2050. This goal includes an interim target to achieve a resource mix that's 65% clean, with 45% of our portfolio coming from renewable energy by the year 2030.
Consumers Energy is committed to achieving net zero methane emissions by 2030 and net zero carbon emissions by 2040.
Centerpoint Energy is committed to reducing our emissions attributable to natural gas usage within the residential and commercial sectors by 20 to 30% by 2040.
Centerpoint Energy is committed to a 70% reduction in operational emissions by 2035.
Dominion Energy is working hard to achieve net zero greenhouse gas emissions across all our electric and gas operations by 2050.
NiSource has committed to a 90% reduction in greenhouse gas emissions by 2030 and a complete elimination of coal-fired generation by 2028.
The New York Power Authority is committed to helping New York State achieve 100% zero-emission electricity by 2040.
I'm Jeff Burleson, Senior Vice President of Environmental and System Planning for Southern Company. Back in 2020, Southern Company committed to a goal of achieving net zero greenhouse gas emissions by the year 2050. We also set an intermediate goal to cut in half our greenhouse gas emissions by the year 2030.
TVA has firm plans in place to reduce carbon 70% from the 2005 levels, and we look forward to developing additional solutions that will help us reduce beyond that 70% in the years to come.
Xcel Energy is leading the clean energy transition as the first major U.S. power provider to announce a vision of delivering 100% carbon-free electricity to our customers by 2050, with an interim goal of cutting carbon emissions 80% by 2030.
By 2050, Duke Energy plans to achieve net zero carbon emissions. It's ambitious, but we're well on our way. Since 2005, we've exceeded expectations and lowered our carbon emissions by 39%. We've accelerated our timeline to retire coal plants, expanded our renewables portfolio, and we're on a mission to do more. We're a clean energy leader, and we'll do our part to tackle the challenges of climate change. By generating cleaner energy, modernizing the electric grid, and building a future that creates value for our customers, our communities, and our shareholders.
Imagine a world with 100% clean energy. We are. That's why we're committed to 100% carbon-free electricity by 2050. To reach our vision, we will eliminate the use of coal, add more solar with storage to harness Arizona's sunshine, and continue to invest in vital carbon-free resources. It's a bold vision that will take all of us to achieve. Together, we can create a clean energy future.
We're at Garland Solar facility today near Bakersfield, California. My name is Jeff Burleson. I'm Senior Vice President of Environmental and System Planning at Southern Company. In my role with the company, I actually have the opportunity to sort of oversee and lead our net zero strategy, as well as our long-term generation planning and generation development. In May of 2020, Southern Company set an ambitious goal to achieve net zero greenhouse gas emissions by the year 2050. What that means is the company is going to do all we can to reduce our direct emissions of greenhouse gas. Net zero in terms of greenhouse gas emissions is really important for not just our company, but for the overall U.S. and the world in and of itself. Ultimately, the intent here is to try to limit global temperature rise. The objective is to try to keep it from a net zero standpoint to 1.5 degrees C or less. We've already made a lot of progress towards our greenhouse gas reduction efforts. In fact, through 2019, we had reduced greenhouse gas emissions by 44%. And through the end of the year 2020, we've reduced greenhouse gas emissions by more than 50%. And that's compared to our baseline year for greenhouse gas emissions, which is 2007. Our 2050 goal is a very ambitious goal, and it's going to take a concerted effort for us to be able to achieve net zero emissions. What we're going to have to do, obviously, is to continue to transition our generation fleet towards low and no emitting generation resources. We're also going to have to continue to reduce the carbon impact of our natural gas business. Solar is going to play a big role for us in achieving our net zero goal. Particularly in the Southeast, where our regulated utilities are, solar is our best resource. But of course, in other parts of the country, wind plays a big part as well. So we're not only trying to drive improvements and lower greenhouse gas emissions in our southeastern states, we're trying to help the entire economy in the rest of the United States do that. And we're going to have a focused effort on technologies that really will sustain and enable us to achieve net zero. Those technologies would include things like long duration energy storage. They would include energy efficiency technologies, carbon capture and sequestration, advanced nuclear, electric vehicles. We've got to ensure that we get strong proliferation of electric vehicles. It's going to take all of those things working together in order for us to be able to achieve net zero overall. Once you get to high penetrations of either solar or wind generation, you need some energy storage to really back that up. And battery storage is a good short and intermediate duration storage technology to be able to do that. Energy storage is going to be an enabler to allow us to integrate in large amounts of solar and wind into the overall generation mix. And in addition to that, negative carbon solutions, planting trees or other things like that, biomass generation with carbon capture and sequestration, or direct air capture, some technologies like that. So this is an ambitious goal to get to net zero by 2050, but we've already got a great start. One of the nice things is that Southern Company has been able to reduce greenhouse gas emissions thus far without any mandates. We've been able to do it because of the economics of retiring some of our coal plants, implementing solar, implementing energy storage, implementing wind. Those things are cost effective for our customers, and with the right research and development focus, we'll be able to drive down the cost of those other low and no carbon resources to the point where we'll be able to achieve net zero in an affordable and reliable way for our customers.
By 2050, Duke Energy plans to achieve net zero carbon emissions. It's ambitious, but we're well on our way. Since 2005, we've exceeded expectations and lowered our carbon emissions by 39%. We've accelerated our timeline to retire coal plants, expanded our renewables portfolio, and we're on a mission to do more. We're a clean energy leader, and will do our part to tackle the challenges of climate change. By generating cleaner energy, modernizing the electric grid, and building a future that creates value for our customers, our communities, and our shareholders.
Imagine a world with 100% clean energy. We are. That's why we're committed to 100% carbon-free electricity by 2050. To reach our vision, we will eliminate the use of coal, add more solar with storage to harness Arizona's sunshine, and continue to invest in vital carbon-free resources. It's a bold vision that will take all of us to achieve. Together, we can create a clean energy future.